Hello, Honors Pre-Calc BC. All right, so this is your weekend video to give us more time for our late start. I want you to start off by taking a couple minutes to go ahead and copy down these different graphs on your note sheet. So this is the library of functions or parent functions that I would expect you to know what they look like and be able to replicate these by hand without your calculator. So to start, we have a constant. When we say constant, we're talking specifically about a horizontal line, and it would have an equation f of x equals b. B also representing your y-intercept, and just the y coordinate, actually how high up or the y level that each of your points is going to be at. Okay, so all of these would be at the same height as your y-intercept. Linear, we should be familiar with y equals mx plus b. Okay, so we have a line here. Another type of linear equation is an identity. When we say we have an identity, we are specifically talking about y equals x. Okay, so with a slope of 1, y-intercept of 0 going through the origin there. Okay, moving on, quadratic. This is also sometimes called a square function. We should recognize that as f of x equals x squared. Alright, sorry, so we had morning announcements, and I kind of forgot where we left off. I think we were talking about quadratics. So we have f of x equals x squared. You should know that in this situation, we do have a vertex at 0, 0. We're going to be talking on Monday more about how to find other vertices, but this just for this parent function, vertex at 0, 0, and we have important points of 1, 1, and negative 1, 1. Because as you know, when you square a negative as well as a positive one, you do end up with a positive. Okay, next is the square root function. That looks like this, f of x equals square root of x. And some important points, we have a turning point here, not really a vertex, but we'll call it a starting point or a turning point at 0, 0. And then two other points that would show up would be 1, 1 and 4, 2. Because square root of 1 is 1 and square root of 4 is 2. Obviously, there would be other points continuing on as well. Cubic function looks like this guy, f of x equals x cubed. You would have important points at 1, 1 and negative 1, negative 1, because 1 cubed is 1 and negative 1 cubed is negative 1. Also a turning point at 0, 0. So again, these can be adjusted. We can have shifts, which we'll talk about in the future, but all of these parent functions have generally, at least for these three, go through the origin. Next, cube root. So the cube root function looks like f of x equals the cube root of x. Notice that it has the same important points as the cubic function, but it's kind of almost rotated and looks a little different like this. So it's a little flatter. We're going to talk more about that in the coming days and weeks. Absolute value function, we've already seen this one quite a bit. We know that it looks like a V, again, vertex at 0, 0, and we'll have points at 1, 1 and negative 1, 1, because the absolute value of negative 1 is still a positive 1. And finally, move this over here. So finally, we have the reciprocal function, and the reciprocal function looks like this. Okay, the reciprocal function is 1 over x. So I mentioned that this is one that we were going to get to, that you should know what it looks like. And now when I show you 1 over x, you should know that that looks like this. You have the point 1, 1 and negative 1, negative 1. And then we also have these important points here, 1 half 2, 2 1 half, negative 1 half, negative 2, and negative 2, negative 1 half. That just comes by plugging in a 2 or a 1 half in for x, and then of course it becomes the reciprocal to give you the y coordinates. So you'll notice that your y coordinates here are both reciprocals, your y and x coordinates, I should say. So all right, take a minute to go ahead and copy that down, those if you need to. And next, we are going to go on to this. All right, so the last thing we're going to talk about today is something called the greatest integer function. This is a function that represents the greatest integers less than or equal to x. All right, so what's a little weird about this is that it means your number is not going to round up. And this graph actually appears as a step function. Okay, so your notation is going to look like this. F of x equals int x, or it's got like these brackets. your domain is all real numbers. Okay, so you can use any x value you want. Your range is actually all y's that are the set of all real integers. All real integers, and there is actually a symbol for integers. It's like a z. It's something like that. It doesn't get used very frequently. So, okay, we're going to skip the one in the middle. That one is not as important. Go ahead and fill in the table for your first and third one here. We're going from -2 to 1.5 for both of these. And the reason we want to have decimals in here instead of just jumping by ones is, again, to really see how the greatest integer function works. We want a situation where normally we would round. So we want to have some 0.5s to see how this works here. So, okay. Once you fill this in, feel free to pause the video whenever you need to, if you need more time to write stuff down. We're going to take -2. We're going to plug it in place of x. And you're rounding down to the next smallest integer. Now, in this case, -2 doesn't round at all. It would just be -2. Okay, we're going to fill in the table first, then I'll show you how to graph it. All right, so now let's plug in the next one. Integer of -1.5. So -1.5, it will round down, okay? Greatest integer function, I know that's confusing, but you are rounding down. So what is the closest integer rounding down? That is also -2. Okay. Greatest integer of -1 is a -1. Okay. -0.5, again, you are rounding down to the closest integer, always rounding down. So that is -1. All right, so go ahead and start filling this in. When we plug in a 0, well, that's just a 0. And when it's a whole number like that, or an integer value, it just stays the same. It's when you have a decimal that you plug in, or a fraction, that's when you're going to round it down to the nearest integer, or to the lowest integer. 0.5. All right, so 0.5, you're rounding down to the closest integer, which is 0. 1 is already an integer, so it's 1. 1.5, we're rounding down to the smallest integer closest to it, which is 1. So again, this is going to look like a step function. -2 is here, and then -1.5 -2 would be here. And in fact, all the way up to -1. Okay, if it was like -1.1, it would still round down to -2. So actually, this whole part in here is all going to round down to -2 until you get to -1. And see, when you get to -1, you're at -1. Okay, we're going to have an open dot there, and now we come up. And we have a closed here. Let's get this graph and then I'll explain it a little more. And of course, I'm happy to explain this again on Monday. So now we're at -1, and this is going to be at a level, a y coordinate of -1, all the way until you get to 0. That's when it changes. So we're coming across 0. Okay, but at 0, you are actually at 0. So when you go up, it is closed. And this just continues and makes a step function. Okay, so basically when your x value is anything between -1 and -2, rounding down to the closest integer means your y coordinate will be at -2. Okay, that's why we're down here at -2. When you are between 0 and -1, anything's going to round down to -1. That's why our y coordinate here is -1, and so on and so forth. Okay. All right, we're going to try this one. The only difference is that once you get your y coordinate, we're going to double it. Okay, this 2 in front means it's going to double. So if you want, just go ahead and take these values here, and we're just timesing all of them by 2. All right, so the key difference here is it's just taking this graph, same thing, but it's going to be a little more stretched out because look, we have numbers all the way down to -4. So anywhere from -2 to -1, we are down at -4. But then at -1, whoops, at -1 for x, we're now up at -2. Okay, and then we're up at 0. Okay, and then we're up at 2. All right, I'm going to be perfectly honest. This is not going to be a huge focus in this class. So if this is stressing you out, please don't worry about it. Whoops. All right, don't worry about that at all. All right, last thing we're going to do is some evaluating. This I think you'll find a little easier. F of 1.2, we're just going to plug 1.2 in. So you want to evaluate the inside first. 1.2 divided by 2 is 0.6. Okay, and again, this is just saying find me the integer that you would get when you round this down. And rounding down from 0.6, the nearest integer is 0. Okay, let's try again. 4.6, plug it in. 4.6 divided by 2 is 2.3. Again, you are rounding down to the nearest integer. 2 is your answer. Okay, and finally, plug in a -0.8. It's going to give you a -0.4. Remember, you are rounding down, so to the left on the number line, and the nearest integer will be -1. All right, there you go. Last thing, we can actually graph these with our calculator if that's something that interests you. All right, so from your y equals, what you would do is go to math and go over to numbers, and it's this option right here, number 5. So then I can type in x and graph. Okay, and I need to do a zoom 6. So there you go. So there's your step function. It doesn't show the open and close dot, but if you go to your table, here, because I'm jumping by ones, I mean, it doesn't really look like much, but if you change your table set to jumping by 0.5s, you'll get the same thing that we had in our table. Okay? Cool. So the reason we have this open dot again versus the closed dot is that this is just representing from -2 up to -1, not including -1. All of those numbers round down to -2. Once you actually get to -1, then our y-coordinate is -1 again. But between -1 and 0, any of those numbers, not including 0, will round down to -1. Okay, so that's why it keeps stepping up. Once you get to the next integer itself, then you have the closed dot again. So, all right, there you go. On Monday, we will be talking about graphing piecewise functions. Ooh, that's what it's going to look like. Very exciting. All right, hope you have a great weekend. Bye.